In my earlier video, I had discussed about what is the nilpotent operator. Also, I had seen when a matrix be nilpotent matrix, which is associated by this nilpotent operator. Also, I had seen the characteristic polynomial, eigenvalue, minimal polynomial, trace, determinant of all properties of nilpotent operator. Today's goal of this lecture is I will see some question about nilpotent operator. At first, I will highly recommend you, if you don't see my previous video, at first see my previous video, because if you see the previous video, then you will understand this question and this option very easily. First question is, which had come CSR NET June 2016 exam? The question is, let T be n cross n matrix with the property T to the power n equal to 0 operator. Then which of the following statement is and are true? Option 1, T has n distinct eigenvalue. Option 2, T has one eigenvalue of multiplicity n. Option 3, 0 is an eigenvalue of this operator T. Option 4, T is similar to diagonal matrix. Okay? Notice here the operator is T to the power n equal to 0 operator. That means obviously this operator is nilpotent operator. We all of us know this is. And here has first option indicate T has n distinct eigenvalue. All of us know in the first video of nilpotent operator I had discussed the characteristic polynomial of nilpotent operator is x to the power n equal to 0 operator, and also minimal polynomial is x to the power n equal to 0 operator. This is minimal polynomial when the operator t is not equal to 0. When t is 0 operator, then the minimal polynomial is x equal to 0, and when t not equal to 0, then by this concept we can tell the eigenvalue of t is 0 with multiplicity n. Okay? Means for nilpotent operator only eigenvalue is 0. So we can tell for nilpotent operator always determinant of this operator is 0 and trace is always 0, because determinant means product of the eigenvalue and trace means sum of the eigenvalue. So option 1 is a wrong option. T has n distinct eigenvalues. This is wrong option. Option 2 indicate T has one eigenvalue of multiplicity n. This is also right option. And option 3 indicates 0 is an eigenvalue of 3. This is right option. And option 4 indicate T is similar to a diagonal matrix. Just recall what is the diagonalizability of nilpotent operator. We all of us know when a matrix or when a linear operator be diagonalizable, then it is similar to diagonal matrix. But we all of us know a nilpotent operator is diagonalizable when only this operator is 0 itself. Otherwise the nilpotent operator cannot be diagonalizable. I had discussed this part in my earlier video elaborately. So T is similar to diagonal matrix. This is not always true. Okay? This is only true when T is 0 operator. So option 4 also wrong option. Are you getting? By this concept, how we can tell about this option? Now I will see one example which had come CSR NET December 2017 exam. The question is, let V be a vector space over the complex number C of all polynomial in variable x of degree at most 3. And here the operator is defined as D from vector space to vector space be a linear operator given by differentiation with respect to x, and A be the matrix of D with respect to some basis for the vector space. Then which of the following statement are true? Option 1, A is nilpotent matrix. Option 2, A is diagonalizable matrix. Option 3, the rank of the matrix is 2. Option 4, the Jordan canonical form of the matrix A is this matrix. Okay. Notice here given D be a linear operator from vector space to vector space, where V be a vector space of all polynomial degree at most 3. Okay, are you getting? Here this operator is differentiable operator, and always differentiable operator is a nilpotent matrix. Since here V be a vector space of polynomial of degree at most 3, so here obviously the matrix representation with respect to the basis, obviously here the bases are 1x, x square, x cube, and the matrix representation would be such type. Notice D of 1 equal to 0, then the matrix representation would be first column would be such type 0.1 plus 0.x plus 0.x square plus 0.x cube, and D of x equal to 1, which is equal to 1.1 plus 1.x plus 1.x sorry here 0.x here 0.x square plus 0.x cube, and D of x square would be 2x, which is equal to 0.1 plus 2.x plus 0.x square plus 0.x cube, and D of x cube would be 3x square, which is equal to 0.1 plus 0.x plus 3.x square plus 0.x cube. Are you getting? Therefore, the matrix representation would be 0, 0, 0, 0, 1, 0, 0, 0, 0, 2, 0, 0, 0, 0, 3, 0. This is the matrix representation. And notice, obviously, this matrix would be nilpotent matrix, and since here the differential operator of degree 3, so obviously a to the power 4 equal to 0. This is the differential operator, and this is the nilpotent operator. Here the nilpotent operator would be such type d to the power 4 equal to 0. So obviously notice here, obviously here the eigenvalue is 0, that means lambda equal to 0, and since the matrix is non-zero matrix, so D cannot be diagonalizable. Okay, therefore this operator be nilpotent matrix, Obviously this is true. A is diagonalizable matrix. This is the wrong option because this is non-zero nilpotent matrix and the rank of A is 2. Notice the rank is here 3 non-zero column. So obviously rank of the matrix, if denote this matrix as A, rank of the matrix is 3. So option 3 also wrong option. And option 4 indicate Jordan canonical form of A is, notice here we have to find the Jordan canonical form. And how we will find the Jordan canonical form of nilpotent matrix, I have discussed in my previous video elaborately. Since A to the power 4 equal to 0, that means obviously this imply there exists one block, sorry, not only one block, one Jordan block of order 4. Okay, and here notice rank of the matrix is 3. Therefore nullity of the matrix would be 4 minus 3, which is equal to 1. Therefore nullity of this matrix is 1. That means there exists only one Jordan block of order 4, and this would be such type. One Jordan block of order 4, such type. Here the eigenvalue is 0. Okay, that means obviously option 4 is a right option. The Jordan canonical form of this differential operator would be such type. Are you getting? One question which had come CS and NET 30 November 2020 exam. The question is, let A be 3 cross 3 nilpotent matrix, then which of the following statement are true? Here not are true, are necessarily true. Option 1, I plus a to the power n equal to I, where some n greater than 0 and where I is the identity matrix we all of us know. Option 2, the column space of A is only contains singleton set 0. Option 3, the eigenvalue of A are root of 1, and option 4, A cube is diagonalizable. See the option again and think at first. This is very conceptual question. Option 1, consider AB 3 cross 3 nilpotent matrix, and we have to prove I plus a to the power n equal to I, where for some n greater than 0, where I is the identity matrix. Consider AB non-zero 3 cross 3 nilpotent matrix of index k. Then, since order of A is 3 cross 3, therefore k equal to either 2 or 3. Consider k equal to 2. Then A square equal to 0. And if A square equal to 0, therefore A to the power m equal to 0 for all m belongs to natural number, and always m greater than equal to 2. And consider I plus a to the power n equal to I, where for some positive integer n. And by binomial theorem, this means I plus nc1a plus nc2a square up to ncn n, we all of us know this is equal to I, because I have considered this is equal to I. And since A be 3 cross 3 nilpotent matrix, so a to the power m equal to 0 for all m greater than equal to 2. That means all part would be 0. Therefore, this value would be I plus na equal to I. That imply na equal to 0. And na equal to 0 imply a equal to zero matrix. Okay? Here I have considered A be 3 cross 3 non-zero nilpotent matrix. But if you assume this equation be true, then I will get A equal to 0 matrix. Therefore, our assumption is a wrong assumption. Therefore, option 1 is a wrong option. And option 2 indicate the column space of A is 0. For this, consider one matrix, one nilpotent matrix. And obviously this matrix is nilpotent because here A square equal to 0. And we all of us know column space is the subspace which generated by column of the matrix. And here the column space generated by these 3 vector. That means this does not contain this 0 vector because here there exists one non-zero vector. So column space cannot be 0 vector for this matrix. Therefore, 2 also wrong option. Here has indicated the column space of A is only singleton set 0. Option 3 indicate the eigenvalue of the matrix A are root of 1. This is also wrong option because we all of us know for nilpotent matrix only eigenvalue is 0. And option 4 indicate A cube is diagonalizable. Obviously this option is the right option because since A be 3 cross 3 nilpotent matrix, so for any index A cube equal to 0 matrix, and we all of us know when a matrix be null matrix, then always this matrix is diagonalizable. So option 4 only right option. Are you getting? This type of example actually very conceptual. Okay? Oh yeah. 2 also wrong option. Here has indicated the column space of A is only singleton set 0. Option 3 indicate the eigenvalue of the matrix A are root of 1. This is also wrong option because we all of us know for nilpotent matrix only eigenvalue is 0. And option 4 indicate A cube is diagonalizable. Obviously this option is the right option because since A be 3 cross 3 nilpotent matrix, so for any index A cube equal to 0 matrix, and we all of us know when a matrix be null matrix, then always this matrix is diagonalizable. So option 4 only right option. Are you getting? This type of example actually very conceptual. Okay? I'll see another type of example which had come TIFR 2015 exam. The question is, let n greater than equal to 1 and A be n cross n matrix with real entries such that a to the power k equal to 0 for some k greater than equal to 1. Since a to the power k equal to 0, that means obviously the matrix A be nilpotent matrix. And let I be identity n cross n matrix. Then option 1, I plus A need not be invertible. Option 2, determinant of I plus A can be any non-zero real number. Option 3, determinant of I plus A equal to 1. Option 4 indicate A to the power n is a 0 matrix. Here notice A to the power k equal to 0 operator for all k greater than equal to 1. That means obviously this matrix is nilpotent matrix. And we all of us know eigenvalue of nilpotent matrix always be 0. Here in the option 1 indicate I plus A need not be invertible. And I plus A means Since eigenvalue of nilpotent matrix is 0, means I plus A, determinant of I plus A actually would be 1. Since here all value be 0, that means this condition is 1 plus 0, right? So this is not equal to 0. So option 1 is a wrong option, because option 1 indicate I plus 1 A need not be invertible. So option 1 is a wrong option. Option 2 indicate determinant of I plus A can be any non-zero number. This is also a wrong option, because not any non-zero number, here only 1. So option 2 also a wrong option. And option 3 is a right option. Determinant of I plus A equal to 1. And option 4 indicate A to the power n is a non-zero matrix. Notice here this is the nilpotent matrix. So we all of us know characteristic polynomial of nilpotent matrix would be x to the power n equal to 0. So by Cayley-Hamilton theorem this satisfies a to the power n equal to 0 operator. So obviously a to the power n is a non-zero matrix. This is also wrong option. Are you getting how the nilpotent operator and nilpotent matrix are very important for any competitive exam? Oh well. Today I will stop here. In my next video, I will discuss new type of operator, idempotent operator. But at first I will highly recommend you, please see today's video with pay attention, because these concepts are very important for any competitive exam. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.